Okay. All right, you guys, we are going to run this last portion of our activities where we can assemble. Michael brought this up. It's a great idea. What if we collect a bunch of STL files from our students, one from each of them, whether it's a scan of theirs that they've already cleaned up, or it's a file from Thingiverse, which is like an open source thing that I will share with you guys a link to. That makes it like kind of nice and easy to download easy free STL files. What if we have them all send us a mesh file and then assemble it into one object so we can print one thing, at least print one thing per class for them. And with the help of Bailey and Aaron, and other folks, we've been able to kind of troubleshoot this process. So we have printers at the school that we can use for 3D printing now, and they should be operational. I'm going to run a test on this, and it should work. But you can see here in my Blender file, I just basically created a new file, and I imported a lot of different STL mesh files from Thingiverse, and then I scaled them to be a size that I wanted. And I started kind of just overlapping them and putting them in the same kind of like overlapped space together with my move tool and rotate tool and different tools. So you can see if I click on one of these, there's a ton of little like layers over here that we're looking at. I'm going to add one more just to show you the process. So file, import. I'm going to import one more. STL is what we're working with, because that's the type of file that we're exporting and importing from Thingiverse, or importing from Thingiverse. So now I'm going to go to my hard drive. I have a little folder that says Thingiverse files. These are files that I've been downloading. And I'm going to choose my little hammer STL, importing that. Okay, this is, you can see, you can't see it. It's actually really big right now, the hammer. Whoa, it's way big compared to my other objects. So I am going to scale that down with the scale tool, making sure I'm on that layer, and I'm going to start dragging this circle inward. And just repeat that step many times. Don't go beyond the inner circle. Just drag the outer circle in, and you'll start to get this scaled down. And you guys just do this whatever. This also constrains the proportions if you just do this from the outer circle, which is kind of nice. Get it kind of to the size that you want it, whatever your object is. And then by looking from different viewpoints, I'm going to rotate this 90, move my little thing. I'm going minus 90 here, minus 90 degrees. And then I'm going to move this up from this view, and then I'm going to get into the top view, and I'm going to move this over. Bam. And I want to kind of place this here, because there's a hole in that funnel that I'm not happy with, and I want it to be closed. So I'm placing this right here. Now I'm going to look around at this. Pretty good. Looking pretty good. Cool. I feel fairly happy with this. And when you guys get to a point when you're working with the students and you guys are putting together something like this, once you're finally looking at it and you're like feeling good about what you've composed, you can join all of these objects together. So to do that, you want to use your select box tool and select everything. And then you're going to press Command J. Bam. And that, you'll notice, this step, when you do this step, you can't really reverse from that, and you'll end up with one large object here. One layer, one object, one mesh object. But we were exporting this as an STL and we were having trouble because the geometry, because of all these different files that we're bringing in, it's like not, the geometry's not worked out in the, I guess those like triangles and shapes aren't coming together properly. So you can fix that, but the first thing you want to do is actually apply. So I've been scaling all these to different sizes, and I now want to apply the scale. This is a really important step. Took me a while to figure this out. If you press in object mode after you join it, if you press, or if you select, let me just make sure I do this right. Apply the scale. So if you press Control A and then choose scale, check this out. Once you're selecting here, Control A and then select scale. Make sure scale and apply properties is selected. Then you can click off of that, and now this thing is going to be a lot easier to remesh. That's the next step. So what we were doing is somehow we were missing this part of the process, and we were just going to the modifiers tool and at generating a new remesh. Before doing that, this would take forever. Now, after having applied the scale, you can add a remesh modifier, and we're selecting this voxel modifier. You can see immediately, whoa, that is not what we want at all. We can bring this size down really easily now, and it starts to show you the mesh polygons that are basically being created and generated as we make the size smaller, until we get to a point that we're having a better resolution of this. So I'm at 1 right now. Let me look at this. You can see once you start getting to a lower size, your computer starts to have to work a little more to do this, because it's going to generate a lot of little polygons. Bum bum. So I'm at 0.1 right now. I don't know if I want to go much further than this, but I am going to go a little bit further, because this could be more resolved, some of this stuff. But for the purpose of what we're doing, I don't really think we need to worry about this being super resolved. So I'm just going to go down, if possible, voxel size. Nope, let's stop there. We're at 0.1. So let's now apply this. So we have the modifier, we have the voxel, we've changed that to 0.1. That's like as low as it gets, which I think is good. Let's stay at 1. Or let's stay at 0.1. Hold on. Computer's working. You can see. Whew. Hang tight. Okay, so we're at 0.1. So now I am going to click on this little arrow and click apply, and it should just take a second for this to be applied now, which is going to make our life easier. So before, that was taking like 15 minutes, and people's like softwares were crashing. So now the scale portion is really important. So now we are going to export this as an STL file, and then we're going to bring it into our slicing software. So I'm going to title this like final test. Ooh, okay. And I am selecting my desktop. I'm just saving this to my desktop, you guys. Exporting as an STL. Look, it's doing it. This time it didn't take very long, which is great. Closing this out. Okay, I'm gonna close Blender, and I'm not even gonna save this yet because I don't need it anymore, and I still have the previous version, so I'm not saving that. I'm just closing this. Okay, so now I have my final test. Now, you guys, I'm gonna open this in our Bambu Studio slicing software, which if I double click this, it should just open up in that. This slicing software is on the desktop computers in the digital fabrication lab. So you can see this is loading. Before I was having some difficulty with this where it was taking a really long time, but now it seems like it's going to go faster. While it's loading, let's look at this. These are some of the settings that you want to have set. So the diameter, okay, it's asking me it's maybe too small, but we can just say yes, scale it to millimeters, and it should come in. So the diameter should be 0.4 of the nozzle diameter. Flow is standard. We are using a preset setting that's called PLA Basic Filament. That's the type of filament that we're using, so make sure that that's on your slicing software when you use this. There's a 0.16 optimal. That shows you, these should be the normal things that pop up when you choose that preset, but if not, choose this 0.16 millimeter optimal BBL, and then let me move this out of the way. So initial layer height 0.2, layer height 0.16. Cool. Now the other thing we want to do is enable the supports, because there's going to be overhanging sections in your print, and they need to be supported to be printed. So I am going to click on enable. The type I want is tree, and angle, this is already a preset, so I'm just leaving it at 25. Now I can see this is now showing me the slicing bed, the printing bed, and it's telling me it's laid over the boundary. So what I'm going to do is scale this down with this little scale button to let it be the right size for printing, or to scale it to be the right size for printing. And you see that error went away now because it's actually sitting on the entire printing bed, right? Let's look from the top view. Take it from the top view. There we go. So you can see there's room around the entire edge of this, which is important. You can print up to 10 inches on this, but I think it's better for what we're doing maybe to keep it 9 or less. And I can click on this little section and hold it and drag this around and look at what I'm doing. No. I might scale this a little bit smaller because this is a test and I want it to work. So I'm going to scale this slightly smaller. Click on it, and where's my little scale? There we go. I'm going to scale this a little bit smaller by dragging the corner. Okay, cool. Now, what I'm going to do is slice it, because that's going to tell me if this works. So up here, I can click on this slice plate setting, and it's going to go through the process of slicing this file to show us. Oh, this is telling me I still have a lot of triangles. So that when I scaled down the remesh, I probably went a bit far. I could have like actually made that slightly bigger, but this should still work for us. So it's at 80%. It's moving much faster than it was before. So it's generating the G code. And well, I'll show you what it looks like when we get it done. So that says it's working. The slice said it was okay. That little check mark symbol means that it's going to be fine to print. So now you can look up here. This will tell you how long it's going to take to print. This will take 10 hours and 6 minutes to print on a 3D printer. I am going to close this so I can see what it is that I've created. These little curvy things with branches, these are the supports that are actually being created, and they break away quite easily for the most part when you print it, but they're necessary. So now let's drag this down, and you can see layer by layer how this thing is going to be printed, which I think is really cool. So you can see there's an infill that you'll start to see. Let's fit this to the camera. So there's like a little grid in there, a honeycomb grid that's like being printed along with the other things. And then these layers, they're just building up over time as the printer moves around and prints this. Pretty neat, I think. Okay, so now I have my G code. I know it's going to work. I know it's going to be sliced. I am actually going to click on print plate on this little arrow, and I am going to export the plate sliced file. So I'm exporting this, clicking on export, and then I'm going to name it. Let's name this. Wait, cancel that. Let's try that again. Sorry, I just erased the file type. Don't want to do that. So I'm going to name this final test. Workshop 3. So I'm saving this on my desktop, and should just take a minute. And now I can take this, put it on a micro SD card that's up in the 3D printing lab, and then put that little SD card in the 3D printer and start my print. And in 10 hours, it could be finished, which is great. So I'm going to try that. And if you're looking at this tomorrow, or if you're watching this video, it means that our printers are working. So thanks, everybody.